Austin, what do you think? Come on, think about it. Identify the problem. When you hear that, what does that tell you to do? Matt?
Find out what the problem is.
Yeah, find out what the problem is. Pretty simple. Find out what the problem is. Step 2, collect information. Okay. So here, let's do this. I'm trying to print a file to my printer. And every time I send the file, nothing comes out of the printer. Okay, what's the problem?
You don't have any paper.
Printer sucks.
You don't have any paper.
Not necessarily.
Clicking the wrong button.
Mike,
It's not printing.
it's not printing. That's the problem. Okay, printer's not printing. That's the problem. Okay, number 2, collect information. What does that imply? What should we be doing here, number 2? Zane.
Collecting like information about a certain subject.
Okay, so in the context of our printer problem, what is some information I should start collecting?
You should figure out what is broken or what needs to be put in
So what question should I be asking?
what kind
If
of
my
thing
printer
can
doesn't.
fix the printer.
Let's try a little more specific. Honestly, guys, think about this for a minute. You're the person in the classroom or at home and your printer's not working.
Is it plugged in?
There we go. Is it plugged in? You'd be surprised how many people don't even realize which electronic device is not plugged in. Like the person who gets their laptop for the first day and they don't understand it needs to be plugged in. Wow. Those are fun days. All right, so is it plugged in? Something else we should be asking ourselves. What other information should we be collecting?
How can we fix it if it's not? If it is plugged in?
All right, so if it is plugged in, what other questions should I be asking? Does it have paper? Right?
That was
Okay.
what I was thinking earlier. Thinking.
A little too early on that though. Yes.
Does it have ink?
Does it have ink? Is it jammed? John Morgan. That's usually my problem. If the thing is jammed, I get mad at it.
Hey, you press the wrong button.
Has it ever worked? Well, that's a good question. Zane?
Is it linked to the computer?
It's a connected to the computer. Wow, so many great questions that I know you guys probably have had to ask yourself before. Mike, more? Taylor?
Did you press the wrong button?
Did we press the wrong button? Which button would I press that would make it the wrong button?
Enter.
Or like the power button?
Oh yeah, did I somehow turn it off? So yes, is it plugged in and is it turned on? That might help. Make sure the device is on, okay? That's all collecting background information. Notice we haven't done any tests yet. All we've done at this point is collect some background information. Yes, it's plugged in. Yes, it's turned on. Yes, I have paper. Yes, it has ink. And yes, it's connected to my laptop. Okay, that's all of our background information.
But it still won't print.
Still won't print.
Is it jammed?
Step 3,
Yeah,
form a hypothesis. Randy, what is your hypothesis?
printer, probably junk.
Try again, a little more specific.
The printer needs fixed.
What do you think might be wrong about the printer?
Maybe the paper's not on the right track.
Okay, so maybe the paper is on the wrong tray. Let's say I have a single tray printer. What else could be wrong?
Maybe you bought the wrong size paper.
Great. Okay, how would I verify that?
Check to see what size paper it takes.
So checking to see what size paper it takes, that is a form of testing the hypothesis. And we'll talk about that 4-step experimentation process in a minute. So let's say that I
You should go back for a second.
go back.
Yeah, I'm writing down steps.
Yeah.
Should have already had these steps on Friday.
Yeah, well.
So Randy says, I'm pretty sure we bought the wrong size paper. And so we go back and we're gonna test that. And so I test it, and sure enough, I bought the wrong size paper. So at this point, we now reflect on the outcomes of the testing. Do I accept or reject my original hypothesis?
Reject.
That would be accept. And then the really important piece here, especially in today's world, is making sure that we are communicating those results. So you might want to get on the website, and you might want to leave like an Instagram under comments, or this printer is junk, it doesn't accept regular size paper, it only accepts the 11 by 17, hit print on. So that's all part of communicating results. And guys, number 6 is so important when we think about science today. Oops, that's not one thing. And when we think about science, science and scientists don't really exist on their own. Okay, they're constantly doing different experiments, and they're publishing those experiments, and so it's really important that we learn to communicate those results. How many guys subscribe to any scientific Twitter feeds? No one? I know, it's so weird. You use Twitter to actually learn something. No. ScienceDaily.com is a really great place to go for just short, easy reads on what's going on in science today. Lots of new findings. It's a really cool place to go. So if you ever follow them, it's called Science Daily. So let's go back here. I want to go back a little bit.
I think guys told us just to watch the videos.
Alright, so remember we talked about testing our hypothesis. And this is something you guys have seen over and over again. It should not be a big surprise. We're going to throw them all up here. Oops, too far. So the first 2 steps of testing is to state your purpose. Why are we testing this? And then the procedures. These are the steps we're going to follow. And anytime that you guys hear about experiments taking place, one of the first things that scientists do to verify the outcomes is they look at the procedures that the scientists followed, and they make sure that they've identified all the control variables. And that's something we're going to talk about tomorrow. And a lot of times when you guys hear studies that are done, not every single study that's done in science is done properly. And so, and I know it's sometimes hard to believe, and we always think of science as being this final say. And it's not. It's really up for debate on a lot of different issues. So it's really careful when you guys, allow yourselves to just take it as is. Try to actually read through the study. And ask yourself, okay, is this real? Is this really what's happening? Do I agree with this? And I think that really makes yourselves a better person, makes yourself more educated to be able to read these. And you can learn a lot more when you critically analyze what the other scientists are having to say. So after the procedure, we then write down our observations. What did we notice from doing that lab? What were some of the outcomes? And then after those observations are done, we then draw that final conclusion. And then we're right back to step number 5 in our scientific method. Do we accept or reject our hypothesis based on the conclusion from the experiment? Always remember, in science, all of our conclusions are tentative. What does that mean? What does tentative mean, Taylor?
We had this word for doing this, we can look at the, how we did. I don't even remember the.
Anybody can tell me what tentative means? Dakota, what about you?
Not always gonna be like agreed on.
Somewhat.
Change.
It can change, yes. Temporary. Okay, so tentative means temporary. So when we talk about maybe having a tentative arrangement, we're gonna kind of go with this arrangement for right now, but it could easily change in the future. So all conclusions in science are tentative. There's always new studies being done, there's new results that are being found, so you never know what might change. All right, we're gonna save variables for tomorrow. And then I have an activity for us to do today. So let's go ahead and practice this. And have you guys do this on a worksheet.